Hello everyone, welcome to another video, and today we are going to solve the equations of motion by the graphical method. And for all the three proofs, we are only going to use this one diagram. So without wasting any more time, let's get started. So let us start off with the first proof, that is the first equation, which is V equal to U plus AT, and we have to prove this using this diagram. So what do we have here in this diagram? Let's look into that first. We have drawn a graph. This is the x-axis, this is the y-axis. Towards the x-axis we have time, towards the y-axis we have velocity. Now we might be asking, why have we drawn time towards the x-axis and velocity towards the y-axis? Always remember that the term which is independent of anything else is always written in the x-axis. So time is not dependent on anything. Velocity is dependent on time. That whatever distance you have traveled in certain amount of time. So whatever is the time, that will determine what is the velocity. But is time dependent on anything? No. So since time is independent of everything, it is always written in the x-axis, and since velocity is dependent on time, it is written in the y-axis. So that's just for the understanding, the logic purpose. Next we have drawn a graph here. It is a velocity time graph. So the body's initial velocity was u, it was not 0. We are assuming that the body already had some velocity. So initial velocity was u, that is it was at the point A. From point A, the graph went up to point B, means the velocity has increased. This is the increase in velocity. How much time did we take? We took t amount of time. As you can see here, the t time is given. So in time t, from 0 to t, as the time changed from 0 to t, the velocity changed from A to B. So what we have given, since A is the initial point, that means the velocity up to A should be u. U is our initial velocity. So we have considered OA as u. Similarly, as B is the final point of the velocity, so we have given this as final velocity. That means D to B, this whole line should be V, capital V. As you can see here, we have given this as capital V. This whole thing is capital V. Means final velocity. This is the initial velocity, the velocity has changed and has become final. Just in terms of numbers, if you have to think, suppose the velocity was 5, it has increased to 15. So this is our 5 and this is our 15, for example. So in terms of variable, we will write u and we will write v. I hope that is clear. So this is our initial, this is our final velocity. Now, as this part is, we are joining this line by drawing a perpendicular, and we have also drawn a perpendicular from B to D. Okay, from A to B was the graph, A to B. We have drawn a perpendicular BD and we have drawn AC, another perpendicular. As a result, what has happened? These two have become parallel, and this has become a rectangle, this has become a triangle, right angle triangle and a rectangle. Okay, so as this part is u, as I have said, this is our u, so this whole part is going to be our initial velocity u. So if this is u, the opposite side of a rectangle is always equal, so this part is also u. As this part is v, so we have given this as v. So now what is the difference between the initial and the final velocity? This is our final velocity, this is our initial velocity. So if I take the final velocity and remove the initial velocity from this, we are left with this part. Am I right? If we take the final velocity and we remove the initial velocity from this, then this part is removed. So we are left with this part. So this is the change in velocity, this is v minus u. So I hope you understood what is there in the graph. Now let us move to the proof. So we have to prove this formula. So we are going to use the formula for acceleration, which we know. We know that acceleration is change in velocity by time, and that is what we have written. Acceleration is change in velocity by time. So acceleration means A. Now change in velocity means final velocity minus the initial velocity. So what is our final velocity? This final velocity is B to D, right? This line is the final velocity and this is the initial velocity. Hope you remember when I explained the graph. This is our final, this is our initial. So we are going, since this is initial, we can take CD and OA. This part and this part are equal, right? So what we have done, we have taken BD and we have subtracted CD from this. See, BD minus CD, BD minus CD. So what do we get? BD minus CD is which part? BD minus CD is this part, which is BC. And time is this one, time. Which is the time? Time is here, time is OD. O to D is the time. OD is the time. Okay, from the everything we are writing from the graph. Just look at the graph and place the values here. So what is BC? BC is V minus U. V minus U, BC. So in place of BC we write V minus U. In place of OD, what do we write? OD is the time. So we write in place of OD T. Now we do a side change. A and T becomes multiplied. So it is AT equal to V minus U. Now if we change the side, we will get V equal to U plus AT. A very simple proof, the simplest proof of the three. We have three proofs. Out of this is the simplest. So I hope you understood this proof. Let's move on to formula number 2. Let's move into the proof of the second equation, which is S is equal to UT plus half AT squared, and we have to prove this. We will use the same diagram, so don't worry about the diagram, just know how to draw this diagram and we will derive all the equations from this one. Okay, so let's start. We want distance traveled. Since we have to find out distance, so we will use the distance traveled. So what do we know from a graph? We have already studied previously that whenever we have a velocity time graph, the area under the graph of a velocity time graph will give us the distance. Okay, so whatever graph you have, here we have this graph from A to B and we have joined this. So this whole region, if I take a different marker, this whole region is actually the area under the graph. Am I right? I hope you understand. Since this is our graph, this whole thing, this whole shape is the area under the graph. So whenever you find the area under a graph of a velocity time graph, this is a velocity time graph. So area under a velocity time graph always gives the distance. So we have written distance traveled is equal to area under velocity time graph. This should be known to you by now. Okay, this is there in the theory part of the chapter. So we need to find area under VT, means we need to find the area of OABD. This whole thing we need to find the area. So we have written area, distance traveled is S, area of OABD. This is what we need to find. Now we have split OABD into two parts. One is the triangle, this part, this is the triangle, and the other is the rectangle at the bottom. Okay, so this is the triangle and this is the rectangle. So we have written area of triangle ACB and the area of OACD. Okay, so we have one triangle and we have one rectangle. What is the formula of area of a triangle? It is half into base into height. So written half. What is the base of ACB? AC is the base. So half into base into height. Height is BC. So we have written BC, half into base into height. What is the area of a rectangle? Length into breadth. So we have taken breadth as OA and length as OD. Okay, fair enough. Length into breadth and half into base into height for the two. Now what is AC? AC and OD are equal because they are opposite sides of a triangle. Now OD we know it is T. So in place of AC we have written T. BC is this part. BC is V minus U. So we have written V minus U plus OA. OA is U. So we have written U. OD is T. So we have written T. Now what we have to do, see here we have the UT, this part UT. So we have brought this at the beginning. UT plus half, then we have T, we have V minus U. But what we need is half AT square. So we need to bring acceleration. Now we know, look at this part, we know that acceleration is equal to V minus U by T. This is acceleration, right? So we need to bring this portion somewhere here. But we have only V minus U. We don't have divided by T. So what we did here, we wrote V minus U, we divided it by T. And by dividing it by T, we gave one multiplication of T. So why did we do that? So that by writing something and dividing it and multiplying it at the same time. Suppose I tell you that 2 by 3 into 3, this thing is equal to what? 2, right? So I can write 2 in this form. Suppose I give you a number 5 and I tell you that 5, writing 5 and 5 by 2 into 2 is the same thing. Obviously it is the same thing. I will divide, cancel out this 2, I will get 5 back. So this is the same thing we have done. For V minus U, we have written V minus U, divided it by T, multiplied it by T. So ultimately T and T will cancel, we will get back the same thing. So what has happened here, you see, half is there, V minus U by T is what? V minus U by T is acceleration. So in this place we can write A, and T into T is T squared. So ultimately we have got UT plus half AT squared. Everything is from the graph, everything, just for this step. Only in one place you have to use some creativity. You have to use the creativity of your mind, where in order to bring acceleration, you have to see that V minus U is there. I need what? I need division by T. So I divide it by T, and since I have divided it by T, I must multiply it by T as well, so that the value remains the same. And then we have the proof, we get the formula. So this is how we solve second law or second equation of motion. Let's move into the last one, that is the third equation of motion. So we are on to the last proof, that is the third law of, or I mean the third equation of motion, and here we have to prove v square minus u square is equal to twice as. This is the second simplest. The second equation we did was kind of the toughest of the three, although that was also not that tough, but that was the toughest. The easiest one is number 2, the moderate one is the equation number 3. So let's see what we have to do. Again we have to find what? We have distance out here. Okay, so we will use the formula of distance again. Distance traveled is equal to area under a velocity time graph. Same logic as I applied earlier. This time what we are going to do, earlier we had split this whole thing. This is the area under the graph. This blue region, again let me mark it. This blue region is the area under the graph. This whole thing. So earlier what I did, I had split it into two parts, one triangle and one rectangle. This time we are not going to split. We have written area of OABD, this whole thing. Okay. Now what is this shape? This is a trapezium. Opposite sides are, one pair of opposite sides are parallel. See, OA and BD are parallel, and these two are non-parallel sides. So any structure where the opposite sides are parallel, I mean one pair of opposite sides, this one is parallel to this one and these two are not parallel, that means it is a trapezium. So here also we have two sides parallel and these two are non-parallel sides. Okay, so we have a trapezium here. Now we need area of OABD, that is area of this trapezium. What is the formula of area of trapezium? Area of trapezium is half into sum of parallel sides into height. So in this case we need the sum of the parallel sides. So which are the parallel sides? OA and BD are the parallel sides. So we will write OA plus BD. See, OA plus BD. Simple. Then we have height. What is height? Height means the distance between the parallel sides. Anytime you get height in a parallelogram, trapezium, the height of a trapezium is always the distance between the two parallel sides. So in this case OA and BD are the parallel sides, and OD is the distance between these two parallel sides. So OD is the height. We can use OD as the height as it is the distance between parallel sides. So we have written in place of height, we have written OD. So what is OA? OA is U. What is BD? BD is V. So we have written V. And what is OD? OD is the time. So we have written time. And at last we have written S is equal to half into UV plus this one. This thing we have kept the same. T we have changed. From where have we got this? Now in the first equation what did we prove? We proved that we knew that A is equal to V minus U by T. This is what we knew now. Acceleration is equal to V minus U by T. Just do one simple side change. Bring T on this side and take A on that side. So we have V minus U by A. So from this formula itself we can get this formula. So T is V minus U by A. So in place of T we have written V minus U by A. That's it, we are done. Now it's very simple. So U plus V I have just written is V plus U. Same thing, A plus B and B plus A are same. So U plus V I have written V plus U into V minus U by A. Now you see V plus U into V minus U, it is this formula. A plus B into A minus B. What is the formula? A square minus B square. So in place of U plus V into V minus U, sorry, V plus U into V minus U, we can write V square minus U square and divided by A. Here we have a half. So we are almost done. V square minus U square we have got at the numerator. At denominator we have 2 and A. So let's do a side change of 2 and A. Since 2 and A are divided, when they will be side changed, they will become multiplied to S. So we have 2A and S. Twice AS is equal to V square minus U square. Just changing the side and writing V square minus U square equal to twice AS. That is how we prove equation number 3. Everything is from the graph except one thing again, and that one thing is this T. So we need to know that the formula of T is equal to V minus U by A. Just apply that formula and you will get the required equation that we need for the third law. So very simple, 3 very simple equations and very simple ways to solve. And the most beautiful thing or the easiest thing is you need only one diagram. So I hope you understood this video. If you like the video, then make sure to click on the like button and subscribe to the channel if you want more such videos. So thank you everyone for watching, and until next time.